Hey guys, in this video I'm going to go over some of the basic elements of trig equations. So in the past what we've seen are just the functions, sine of x, cosine of x, tangent of x, anything like that. Now those are trig functions. Now what we're going to be talking about are trig equations. Equations meaning that there is an equal sign in there. So we're going to have things that look like y equals and then some trig function. So trig equations are built out of trig functions. So we're starting here with the most general form possible for one of these trig equations. Our general form is y equals a times sine of b of x minus c plus d. So a, b, and c and d are all just real numbers. These are just placeholders that I'm putting in there to show you where these different parts go in the equation. So a is multiplied out here, d is added at the end, b is multiplied inside the sign, and c gets subtracted from x before anything else. Okay, so let's go over what each of these things means. So a is called the amplitude. A is pretty straightforward. It's just how tall the waves are when you graph sine. Also, I'm using sine here. We could also be using cosine. It's the same thing. Okay, but amplitude's pretty simple, and we'll have some examples of what each of these things do to a graph in a minute. B is called, well, I'm calling it the horizontal stretch or compression. If B is large, like bigger than 1, it's going to shrink the period, versus if it's smaller than 1, it's going to increase the period. And the reason for that is that our period is going to be 2 pi divided by b. So one of the ways you can think of this is once you plug in a value of x and you can subtract c from it, before that happens, say b is 2, then all these values of x that we are plugging in are getting doubled because b is 2 before they get plugged into the sign, before they get evaluated through the sine function. So that means that if we're just slowly plugging in numbers starting at 0 and going through 2 pi, we're actually going to get to plugging 2 pi into sine halfway through the period, because we're doubling each x value that we try to plug in. So that means the normal period is going to be achieved twice as fast, only going through half as many x values. So that means that the normal period, 2 pi, we're going to divide by 2. So whatever b is, we're dividing the standard period for sine or cosine divided by b. And so, like I said, we'll see examples in just a minute. C has a special name. It's called the phase shift. That's horizontally shifting the graph side to side. And then D is a vertical shift. D doesn't really come up very often, but it's just there just in case. It means shifting the graph up or down. Okay, so here's a few examples of all these graphs and what they do, what these different parts of the trig equation do to different graphs. So y equals sine of x just is the most basic graph. It's called the parent graph. If we had an example like this, where we are multiplying sine by some number a, all that does is it makes our waves a units tall, both in the positive and the negative directions. And that's all it does. So if you're given a graph and they say, what's the amplitude? You just look at how tall the waves are, and you say that. And either direction you can use. Okay? Then for b, if we had to graph something like y equals sine of b of x, what that does is we have our normal period, but it gets shrunk or stretched from the 2 pi it was originally. Now one period happens over 2 pi over b units. So it's either making it happen faster, it's going through the entire period faster, or it's taking longer and it's stretching it out. And our formula for figuring out the period is 2 pi divided by b. Okay. Now c looks a little more complicated, but if we had an example where there is a phase shift, here what I've done is in dotted line, I've made the original sine graph, and if we have a minus c, that means, here's the unit c, that means that this point gets shifted over c units. And then the graph proceeds as otherwise it would. And the note here is that if we had something like sine of x plus c, that means it gets shifted in the opposite direction. So plus inside the parentheses means in the negative direction. So we took the original graph and shifted it over to the left. And then d is just, say d was positive. If we had sine of x plus d that we were trying to graph, we would shift it up d units. So now the very center of the graph, instead of being centered at the x-axis, is now centered at the line y equals d. Okay, and so I'll have another video where I do some more complex examples where we combine some of these things, but these are just all the building blocks for now.